Hi class, we need to take a look at the uniform distribution. Now, this is the idea of the uniform distribution. Remember that within any distribution, you're talking about a population, and in this case, this particular one, it's actually only going to live within A and B. These are going to be numbers, and then also you're going to have that the main shape is a squared. In addition, the total area is also equal to 1. So same idea as what we talked about the previous normal distribution or any of the skew distributions. Also, as we're looking at this type of a distribution, you could have one actual squared or it could come in multiple squares. The main idea is that if you were to calculate the area of the distribution, it's still 100% of scores or total area of 1. And the main requirement is that the shape of the distribution, it's either going to be a squared or rectangle or multiple rectangles, as you can see this particular one. Same idea as before, area is evaluated as technically probability. So that's for the uniform distribution. It's literally a square or rectangle or rectangles. Now, let's take a look at example 1. And in these examples, you have to look at what the distribution is actually, what does it look like? And in this case, we're told that it's uniformly distributed. Now, these represents the actual minutes of a class length. So when they want us to provide a sketch, a basic sketch will be sufficient. Don't forget the arrows. And in this particular scenario, the classes only go from 50 to 52. So technically, this is 50 to 52, x is equal to minutes. And then this is going to be our p of x. We're given in the problem that the p of x is equal to 0.5. So I'm just going to say that's 0.5. And then the actual distribution, because it says it's uniform, it's going to be a square that actually fits between 50 to 52. The actual title of this one will be class length. And that is actually the sketch of the distribution. As long as you have the units, p of x always goes along the y-axis. That would be it for that one. Now, they want you to find the probability that a specific class is longer than 51.5 minutes. So let me declare the variable. So in this case, let x equal to a class length. Now, let me redraw again the distribution just so that it's clear which portion are we getting the area from. So this is x is equal to minutes. This one goes from 50 to 52 minutes. This is 0.5. And what they're asking us to actually evaluate is that the class length is longer than 51.5 minutes. So let me just zoom in. This is 51.5. Longer means to the right. So this is the actual area or probability that we're evaluating. So at this point, we can just, evaluate the probability of x is greater than or equal to 51.5. So our random variable here is also continuous because of the, area idea. So 51.5, and this is equal to the following. It's going to be length times width. So we just have to calculate that length. So, that's 52, that's 51.5. This is 0.5. So that's going to be a 0.5 times an actual height of 0.5. This is going to be 0.25. So this is our final answer. Now part C, they want us to find the probability that is less than 20 minutes and provide a sketch. So let me redraw the sketch here. So once again, x is equal to minutes. We're looking at 50 to 52. This is 0.5. And this is our P of x. Now, here's the problem, that they're asking for the probability that x is less than or equal to 20. Same idea as before. Your random variable is continuous, so less than, it's actually going to be the same as less than or equal. The only problem is that 20 is out here. And your distribution only works between 50 to 52 minutes. So therefore, outside of that range, we're not going to actually have, any values or the probability being 0. So you don't have anything else outside. So our main event for these specific classes go from 50 to 52. Let me double check that that's what it said, 50 to 52. Anything outside, it's automatically going to be 0. So the answer for this one is just 0. Our event only works between 50 to 52, nothing on the outside. Any value that's outside of the range, it's going to be automatically 0.